Question 6. The diagram shows the curve y equals to fx, crosses the x-axis as x equals to -5, origin, turning point -3, -3, and the line x equals to 3 as your vertical asymptote and y equals to 2 as your horizontal asymptote. Okay, now sketch on the separate diagram the graph of the reciprocal function 1 over fx. Okay, so identify some of the key features of the graph. The minimum point originally, we have -3, -3. X coordinate remains unchanged. And my y coordinate will become -1 over 3. And from minimum, it will become a maximum point. What about the x-intercept? The x-intercept will now turn into vertical asymptote. X equals to -5 and x equals to 0. Okay, whereas my vertical asymptote will now become an x-intercept. And my horizontal asymptote will stay as horizontal asymptote, but now the value is y equals to 1 over 2. Okay, so these are the critical features of the graph. Okay, so and then of course we still look at the shape, but let's draw the graph first. So first we look at the maximum point. So our maximum point is right here, -3, -1 over 3. Then we look at our vertical asymptote. Okay, x equals to -5 and x equals to 0, although it's along the axis, but you still must label. Okay, and this will be the horizontal asymptote, and of course the x-intercept 3, 0. Let's talk about this region here first, okay, whereby we have a maximum point. Okay, since we know it is a maximum point, right, so the graph would be a curve downward this way. Okay, then we look at the top left corner. In my original graph, okay, this is where the data lies. Positive value stays positive, negative value stays negative, so it will still stay in the same region, just that now you have an asymptote over here, x equals to -5, so therefore it has to stay in this region. Okay, but you also see that you have a horizontal asymptote. Okay, so now because of 1 over fx, a reciprocal function, small number will become very big and big number will become very small. Hence my graph will be this way. Because my original data are the y values are positive, so it will never become negative when you do a reciprocal function. Okay, and x equals to 0 is an asymptote, so as you approach, okay, as your graph approach x equals to 0 from the positive side, your y value will approach infinity, so it will go this way. So this is a graph of my y equals to 1 over fx. Let's look at the second graph, y equals to f negative mod x. Okay, we see that the transformation of negative mod x, so let's use some number to illustrate the changes. How about we just use -3 to illustrate the change here? Okay, if I start with a -3, okay, for my x, when I do mod x, I get a 3, and when I do negative mod x, I get a -3, which means that there's no change, okay, for the negative side. But how about if it's if my original number, let's look at this, if it's a 3, what happens? Okay, mod x is still 3, negative mod x, it becomes a -3, which means that after the transformation, actually, it does not retain the property of the value of the graph when x is equal to 3. In fact, it will take -3, okay, after the transformation. Okay, after transformation, it will actually, the function will actually take in the value of -3. If my original value is a 3, it will take a -3, okay, because of the transformation. So in other words, what will happen to my graph? Okay, so if I were to look at f -1 over mod x, the minimum point is still going to stay as minimum point. Okay, I'm going to have -3, 3, -3. As we've seen, there's no change, but I will have another minimum point now. It is 3, -3. Okay, because because the positive side will now x equals to 3 will end up as -3, which means what it means is that you have a mirror image taking the value on the negative side. Okay, so it's symmetrical about the y-axis. You will still have your intercept. and you have a new one, 5, 0. Okay, and your vertical asymptote on the positive side, so this one will be removed, okay, it no longer exists, right? And the horizontal asymptote will of course stay as the horizontal asymptote. If I were to draw the graph, this is y equals to 2, okay, and let's label the key features of the graph first. X equals to 0, I have minimum point, -3, -3. I will also have another one right here, 3, -3. I will have an intercept, originally 5, 0, -5, 0. I'll have another one that's 5, 0 over here. So my graph is actually just, okay, they're symmetrical about your y-axis. Okay. Okay, let's look at part 3. Now we are required to sketch a graph of the y equals to f prime x, which is the derivative graph. So we are essentially looking at the gradient. So let's start looking from the left hand side of the graph, right? So when we look at the gradient, so one useful way of doing is by really drawing a lot of very short straight lines that forms the curve. So as you can see, if I were to draw a lot of very short straight lines, you can see that those straight lines actually are sloping downwards all the way until it hits -3. Okay, so ask yourself, as it sloped downwards, then the gradient would it be positive or negative? Okay, so it's clear that the gradient would be negative, 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 all the way until it hits the turning point. Then your gradient will be 0. Right? Then the next question is, when is this curve, when is the gradient steepest, right, along this part over here? When is the gradient steepest? If we were to look at it, the steepest will have to be somewhere in the middle, the center region. So when you draw the y equals to f prime x, it is not required for you to label the minimum point. You just need to know that the steepest gradient is actually around this region. Okay, and then your gradient, as I draw the small line, you see that my gradient, my short straight lines that represent my gradient, my tangent, okay, all these short straight lines are your tangent. As you draw it along the curve, you see that actually the lines actually slope upward, which means that on this part onwards, my gradient is actually positive. Okay, so likewise, this part here, it slopes down, so this will be a negative gradient all the way until when it approaches the asymptote. So for this two tail, I'll say that the gradient will be approaching 0. Okay, where when you have your x equals to 3 as your asymptote, your gradient will have to tend to, on this side, because it's positive, so this will tend to positive infinity. Okay, so whereby this will tends to the negative infinity. Right, so let's draw the graph, right, with this understanding. In my derivative graph of y equals to f prime x, when x is -3, I will have my x-intercept. And the asymptote will have to, the vertical asymptote will have to stay as well. So as seen here, actually the gradient, since the gradient is negative, so your graph on the left hand side here will have to be negative, very close to 0, and then you will have you will hit a minimum gradient, sorry, you hit a minimum point somewhere around here maybe, and then it becomes 0. So 0 means you are at your turning point, and then once you cross your turning point, then you start to increase, then you get your positive gradient. Okay, and you approach infinity. As for the other side here, as you can see, because it's sloped downward, so therefore your gradient is actually negative. Okay, and then you will go from negative and approach 0. Okay, so essentially when you're drawing your graph for your f prime x, you are drawing the graph based on the gradient. Okay, so you do not have any data for you to determine what is the minimum point, so it is not required for you to label this. Okay, but for the rest of the elements of the graph, you need to label. Okay, and one more thing, look at this two tail, they are approaching your horizontal, your x-axis, so you do have a horizontal asymptote, and that horizontal asymptote is at y equals 0 for this graph. Now we look at the last part, y equals to negative fx plus 3. So when we look at y equals to negative fx plus 3, okay, so this is a series of transformation that happened here. So first, we follow TSST, right? Translate, scale your x, then y, okay? So what took place is actually you have a translation for your x, followed by the scaling of your y. So let's do the translation of my x first. If I were to translate if it's fx plus 3, then the translation would be moving will be the translate x to the by 3 units in the negative x direction. So this would be negative 6, negative 3. And if I were to move on to the next step, okay, whereby I have negative fx plus 3, then it comes to y, right, the scaling. So therefore, the negative would affect my y value, okay. Likewise, for x-intercept, this will become negative 8, 0. Since the negative fx plus 3 does not affect the x, and since it's 0, so negative doesn't affect, so it will stay the same. 0, 0 will then be moved as well. This will become negative 3, 0. So this will stay as negative 3, 0. Vertical asymptote would be moved, so this one becomes 0. And the negative fx plus 3 does not affect my vertical asymptote. My horizontal asymptote will not be affected by x plus 3, fx plus 3, but it will be affected by the negative fx plus 3. Okay, so these are the changes. So when you are you don't have to do it step by step. If you can, you can work it out in your head, right? Okay, now minimum point will now become, because of the negative, so actually flip out, this one will actually become your maximum point, negative 6 and 3. And then I also have my intercept. My intercept will still stay as intercept, okay, just that it's shifted to the left. So I have negative 8 and negative 3, 0. Horizontal asymptote, now it is negative 2. Y equals to negative 2. Graph will be starting from very close to the asymptote, which is a maximum value, maximum point of negative 6, 3. Go down and continue to decrease, because this is also my asymptote, okay, whereas this graph here will also start very close to x equals to 0 and approach y equals to negative 2. Okay, so this will be the graph.